Thanks to everybody for attending this presentation. This is entitled Dev Thumbs, QA Thumbs, and the End of Ready for Testing. I'm going to turn this a little bit so I can see it. First of all, who am I? My name is Clint Hoagland, as just said. I'm a software testing lead here at TechSmith. I work on the Camtasia program. I was not trained as a software tester. As most of you know, there isn't really much university training for software testers. I was trained as a film composer. Actually, I went to college for music theory and later for film scoring. As my friend Eric Davis has said, trained musicians make good software testers, and I think that a reason for that is that we're good at working with groups, we're creative, and we're accustomed to sitting in a room and doing something frustrating over and over. As Jess mentioned, I've been in the industry for about 10 years. I started out in tech support, and then I moved over to testing about 10 years ago. And as I said before, I am currently the software testing lead for Camtasia. What is this talk? I'm going to be talking about how devs and testers interact on the Camtasia program, how we ended up here and why we ended up here, a few tips and tricks that we have discovered that have made things work a little better for us, and this is pitched at people who are not necessarily coders. So if you are not a developer, you should be able to understand this presentation. Okay, what is Camtasia? This is Camtasia. Camtasia is raise your hand if you're familiar with what Camtasia is already. Okay, some people yes, and some people no. It is a video editing program. What it does is it lets you record your screen or bring in videos from outside of Camtasia, and then you can edit them and you can put in animations, and you can make a fancy looking video for the internet, basically. Originally, it was meant for documenting processes in software, and now it's used for all kinds of things. People use it to make marketing videos for the internet. People use it to make training videos for their organization. It's a way for making videos. As you can see, it's got a lot of bells and whistles and a lot of buttons you can click. And part of that is because of its history. It has been around since 2002. You can see the first icon for Camtasia 1.0 up there in the upper left. We are currently on version 9. So there's been a lot of features put in over the years and a lot of complexity added on top of complexity, added on top of complexity, and it is what you would call a legacy application. What is legacy code? Can somebody give me a definition of legacy code? Anybody want to have one? Okay. I'm sorry?
I know it's old code.
Yep, old code is one way to think about it. Michael Feathers wrote a book called Working Effectively with Legacy Code, and he defines it as code that doesn't have automated tests. I'll define legacy code as code where if you change it, you don't know if something bad happened. You have to figure out whether or not something broke after you change code. I'm sorry?
Can I give my definition of legacy?
Sure.
It's more than 6 months.
Oh, wait, you need a microphone. Yep.
So my definition of legacy code is it's more than 6 months old. I didn't write it, and I don't like it.
Okay. There's another definition.
But I really do like what you said there about I can't figure out causes and effects in a way that's clear.
Yeah.
That's insightful. Thanks.
You said you had the official definition there?
I did a lookup, and right now, I see that book also. I see that book on the internet. It's
Yep.
Yes. Right off the top here, I see legacy code refers to application system source code type that is no longer supported. Legacy code can also refer to unsupported operating systems, hardware, and formats. In most cases, legacy code is converted to modern software languages and platform.
Okay. Camtasia doesn't fit that description.
Oh.
It's definitely supported. It is quite old. Parts of it are quite old, but it is definitely still supported. We are definitely selling it right now. Okay, so how is the team comprised? We are divided up into what we call pods. Historically, the way that the team was set up was that you'd have developers working in offices by themselves, and QA would be in another office working with other testers. We have since switched into small cross-functional teams that we call pods, and each pod has got like 4 or 5 developers and a dedicated tester or 2. And we are doing what you could call traditional software, desktop software development, which by that I mean it's driven by releases. We have a big splashy release every year or 2 where we want people who already owned the software to pay for it again. So like you own Camtasia 8, we want you to buy Camtasia 9. So we have releases that we care about. And because we want people to buy those new versions, we need to have splashy features in those releases. And because we want people to, again, to buy those things, we want to market them. And since we need to market these splashy major versions, they need to have a predictable date so that the marketing people know when they can put they can send out their email campaign. They can put things on the internet. So so that we are constrained by these things on our desktop software. This is what's called the iron triangle. This is an idea that came up like in the 50s or something with manufacturing. I've seen it attributed to a couple of different authors, so I don't know exactly who the original author who was it that proposed these 3 aspects of the iron triangle. But the 3 facets are scope, date, scope, and resources. Basically, you can vary 2 of those things, you can vary one of those things, but then the other 2 have to move, right? So if you want to hold date and scope constant, then you need to add more resources. Or if you want to hold scope and resources constant, then you might have to move your date. Does that make sense, everybody? Okay. In the Mythical Man Month, Fred Brooks proposed a law that says that adding manpower to a late software project just makes it later. You can't just throw more people at a software project because people have to learn about the project, which takes time. So what happens in practice is that it's not actually possible to vary the resources on a software project. So what ends up happening is that the quality is what ends up getting varied. So you'll have a lot of you'll have a big pile of things that you want to do and things that you want to fix. And as the date approaches, you'll start descoping some of those things. Like you'll have some must-fix bugs that are suddenly becoming want-to-fix bugs, and some features that were must-haves that suddenly they're going to go into the next release. And I assume that people have had that experience if you're working on software projects. So, an experience that we had, and I'm going to grab a sip of water because my mouth is dry. An experience that we had in 2015 to 2016, when we shipped the 9.0 version of Camtasia, was that we had that problem where we had a fixed scope and date, and the quality was like we were working on the quality, but the quality wasn't in such a state that we could release it whenever we wanted. And customers were calling and saying, Camtasia's crashing all over the place, and we're like, yeah, it's because it's 32-bit. We've got a 64-bit version of this thing coming, but we can't ship it right now because there's a bunch of must-fix bugs in it. So we got that version out, and it's great, and I personally like it a lot. My coworkers said that it's delightful. The customers have had a good reaction to it. But once we got done with that, the business was saying, we don't want to be put in that bind again where you tell us that we can't ship it because there's so many bugs in it. We want to be able to say we have a predictable date, but we also want to say that we can ship whenever we want. Can we fix both date and quality? What we discovered is that in our context, date is less negotiable than scope. The marketing people have what they need. They need what they need in terms of dates and stuff, but they're a bit more flexible about what can go into the product. So we all agree that we wanted to target a level of quality. So then we started asking ourselves, okay, we want to hold quality constant. What does that mean? We decided that the only plausible standard for good enough quality was releasable right now. Any number of must-fix bugs in the product threaten your date. And the reason for that is because when you have a must-fix bug, you don't know how long it's going to take to fix. So any number of show-stopping bugs other than 0 puts the data at risk, because if you have some sort of problem that's in the software, somebody smart already tried to do this thing right and they didn't do it successfully. So more smart people are going to have to think even harder about it for some amount of time. So that means your data's at risk. So that means that we have to have a thoughtful standard about what do we mean by releasable quality. So that goes into so this is my own personal theory about how quality works. In my mind, there are 3 types of requirements that comprise quality. Explicit requirements, implicit requirements, and latent requirements. And I'm going to go into some detail about what I mean by those things. The difference is important between these things because they should be handled differently and they should be handled by different people. Or different roles, I should say, not necessarily different people. Okay, what's an explicit requirement? The explicit requirements are what we agreed the software would do. That's the things that it says on the box. If you were doing waterfall, then the explicit requirements would be captured in a specification. If you're doing agile, it might be captured in user stories. You might have acceptance criteria on a card somewhere and your Trello board or whatever. Additionally, your help file might say that the software does things. Your website might say that the software does things. Those are all explicit requirements, and the software must do those things. So the question is, what's the right role to test for explicit requirements? Who should be doing that testing? And the answer is that anybody can do it, because anybody can read a requirement and then see whether the software actually fulfills that requirement. So the cheapest person, or the cheapest time to test for it is when you're writing the code, because you have the most context about it right then. And as a bonus, you can also write an automated test about an explicit requirement, and that will mean that it's always true going forward. And you may have heard of test-driven development or acceptance test-driven development, and those are both 2 techniques for making sure that you have automated tests for all your explicit requirements. Next are implicit requirements. This is what the users expect it to do. Now, once you have actual live customers, there's the things that you said that you knew that the software was going to do, but your customers might be trying to do things that you weren't thinking of. They've got expectations that you might not have talked about. When you're testing for testing for implicit requirements, it's not practical to document every implicit requirement because they're so numerous. You could have a specification that's thousands of pages long, and you might still not capture all the things that users might hope the software is going to do, or the things that they might get mad about. So how do you handle implicit requirements if that's true? And basically what you need is an expert exploratory tester, and that's why we have a QA department here at TechSmith. We've got people who are trained in discovering implicit requirements that we haven't discussed yet. And finally, we got latent requirements. These are what we call delighters. These are the things that people get excited about even though they weren't expecting them to be inside the product. So my son and I are currently obsessed with this game called Cuphead, which is a video game for Xbox and PC, which basically you're one of these 2 little guys and you fight these bosses, and it all looks super cool. It's they announced it back in 2014, and it took a really long time for them to make it. And the reason why it took a long time is because it's all hand animated. They animated it like a 1930s cartoon. And they announced to everybody at the outset that that's what they were going to do. So that was an explicit requirement that every frame of Cuphead was going to be hand animated. But in addition to that, they fulfilled a couple of latent requirements that were mentioned by lots and lots of reviewers, which one of them was, and the reason why I want to say this is because we want to know how to discover these latent requirements that will delight people. The first one was, they said, okay, we're going to animate this thing like a 1930s cartoon. What kind of music should it have? And so what they decided was, well, back in the 30s, the main kind of music that people listened to during movies or during cartoons was they had big band music. So the Cuphead production team, they hired a real big band to record 3 hours of big band music to be the soundtrack for Cuphead, and everybody mentioned how it's got really good music. In addition, they did lots of play testing because that's something you do with video games. And basically, all of their users said, the game looks really cool, but it's way too hard. So, and everyone said, it looks really beautiful. I want to hear the music. I want to see the images, but I can't make it through the levels in order to see the ones that are further down the line. So what they ended up doing was they had a regular mode, which is the standard difficulty that was way too hard for everybody. And then they added a simple mode, which made it so that everybody else who wasn't that good at video games could go and see what the levels looked like. So, examples of each of these types of requirements for Camtasia. Explicitly, Camtasia should be able to import all kinds of videos. It should be able to publish it to all these third parties that we advertise on the box. Implicitly, it shouldn't crash. I mentioned before that when we had a 32-bit version only, we had a lot of crashing problems because the projects were getting too big. That's been satisfied by 64-bit. Additionally, when we were doing our testing for 9.0, we found that it was getting really frustrating to make projects because the editor performance was really bad. And so that was an example of our testers going to our product people and saying, you're going to have to fix this before you ship this thing because people are going to get really frustrated. That was an example of exploratory testing, bringing to light an implicit requirement. A latent requirement for Camtasia is something, we have this feature called behaviors, which basically what they do is they make your text look really cool. Like you can, instead of having just your text just appear on the screen, it can like fall from the ceiling and do some stuff and then like wipe off or whatever. And it's just like a drag and drop thing where you can make your text look cool automatically. So that's an example of a latent requirement that delighted people in 9.0. Okay, so ready for testing. Historically, the way the desktop software has worked here at TechSmith and probably at other places is that you have a development team over here, you got testers over here, and the development team, they get a feature all ready to go, they merge it into the product, they say, hey testers, this thing that we talked about is now ready for you to test. Will you come and look at this thing? And then the testers will say, okay, we'll look at it, and they test it for a while, they find some bugs, they put the bugs in the bug tracker, and then that goes back to the development team. There are some problems with that approach. And to illustrate the problems, I need 3 volunteers. Oh, before I bring up the volunteers though, anybody raise your hand if you've heard of the concept of Chekhov's gun? Anyone? Okay. Antonin Chekhov was a playwright, and he talked about the rule of Chekhov's gun is if you've got a rifle on the table in the first act of a play, then somebody should get shot before the play is over. These are the Chekhov stuffed animals over here. There is a reason why we have stuffed animals on the table over here. And I've actually gotten the volunteers before because I wanted to make sure I had people. So if the people who volunteered, please come up.
How many volunteers?
A total of 3, and 4 including myself. All right. This is, you can be the turtle, and you'll be the frog, and yeah, you gotta hold the frog while you say the things. Originally, I wanted these to be puppets because I assumed that my kids had puppets, but they don't. They just have a bunch of stuffed animals. Yes, it is. It's Turtwig, but I didn't say that in the script. Oh, we got microphones for everybody?
Yep.
I don't know how people are going to do that. Okay, everybody got your scripts? I've highlighted the parts where you need to talk.
Okay.
Does that work? All right, this is a one-act play about testing in branches. Our scene begins with Mr. Frog, who is a homeowner, speaking with Miss Salamander, who is a home contractor. I like to use home building metaphors when talking about software development. I'll talk about that in a little bit more in a minute. Okay.
Hello, Miss Salamander.
Hello, Mr. Frog.
I'm told you are a home contractor.
That I am.
Do you think you could install a new bathroom in the basement of my house?
I surely can. I specialize in pads, like yours. I can get to work this week.
How long do you think you will be in my house, pad?
I don't need to work in your house at all. I'm a magical contractor.
What?
I'm a magical contractor. What I do is make a magic copy of your house in my workshop. I work on the magic copy. Then, when I'm done, I use magic to switch the copy with your existing house. The bathroom will just appear when I'm done.
That sounds amazing. Let's do that.
And so they did. Miss Salamander built that bathroom and magically replaced Mr. Frog's existing house with the one that now has a bathroom in the basement. It is now 1 week later, and Mr. Turtle is at Mr. Frog's front door.
Knock, knock.
Who's there?
Mr. Turtle.
Mr. Turtle who?
Mr. Turtle, the inspector. I'm here to inspect your new bathroom. I work with Miss Salamander.
Okay, come on in.
The frog works for about an hour and then comes back with a report.
Okay, I looked over the bathroom, and although it technically works, I want you to know about a couple of things. The sink basically works with the stopper thing that lets you fill the sink. That doesn't work. The leak behind the shower, so you can take, what?
I'm nodding my head the contract.
So you can take the shower just fine, but it wouldn't leave it like that. But I wouldn't leave it like that because there's gonna be mold eventually. The toilet flushes just fine, but there's something going on with it where it's running all the time. You should probably get that fixed because your water bill is going to be astronomical otherwise.
Wait a second. Let me get this straight. You guys had a magical copy of this house in your workshop.
Yep,
You built the bathroom in the magic copy, and then you replaced my house with the copy.
yep.
And now you're in what was now my house, telling me that it's got all these problems.
Yeah, they're pretty bad.
Why didn't you check these things before you put them in my house?
Yeah, it doesn't really work like that. It's like this. The builders finish up and then swap in the magic copy, and then I checked it while they're working on the next house.
Meanwhile, I've got a busted bathroom.
Well, I mean, they can come back and fix it
When?
when they're done with the one they're working on, assuming that nothing else comes up.
Thank you very much. Thank you. Thank you very much, volunteers. I appreciate your yeah. I give you credit for coming up in here and doing that for me. Okay, so this is not a joke, though. This is silly, but it's not a joke. Software developers, in this case, are the magical contractors. One reason why I like to think about software development as home building is that you like to think of a building metaphor, but you're never building a new house. You're always working in an existing house. And when software developers start working on a new piece of code for that existing house, they do it in a branch. And they use a thing called source control to create a new branch of the software. And this is a diagram that I stole from this person at grapefruitgames.wordpress.com. But basically, the way that it works is this master branch here, that's the house that's sitting in Mr. Frog's lot. And when Miss Salamander decided to start working on that house, she made this copy here. And she put the bathroom in, and then when she was done, she swapped it back with the existing house. Does that metaphor make sense to people? Okay. So, this is the way a typical desktop software project tends to run. You have people developing over here, you have people testing over here, they're logging the bugs. The bugs tend to accrue over time until you reach some moment a couple of months before you want to ship the software, and you go, oh my God, there's so many bugs, what are we gonna do? And then you start to make a plan about which bugs you're gonna fix first so that you can get done by the date. You start paying down that debt until you finally run out of time, and then you're stuck with these bugs that will ship in the product. So to restate the problem, that now that we've had our amphibians metaphor, the problem that we were having was that implicit requirements were being discovered after the code was already shipped into the product. The turtle was testing a week later rather than working directly with Ms. Salamander. To restate the problem that we had with Camtasia 9.0, our bugs were keeping us from shipping features that users wanted. And the handoff between the devs and testers was needlessly expensive, with tasks being handed back and forth. Like there was this ready for testing column would have cards in it that stood there for weeks at a time. And then the tester would finally roll up and the card would be like, I don't even know what this is. And they'd have to learn about it. And then they would do the testing. They would pass the bugs back to the developer. The developer would be like, I worked on that thing like a month ago. I have no idea what you're talking about. And this would happen over and over. So here's what we're doing about it now. And mainly I want to talk about this first thing. We currently have a 3-tiered exploratory recipe for making sure that this doesn't happen again. And we do testing in branches, we do mob testing, and we do whole team scenario testing. And I'll go into a bit of detail about the first one and then a little bit of detail about the second two. Okay. Raise your hand if you know about GitHub. Okay, so most people know about GitHub, but for those who don't, GitHub is a source control repository, which lets you put your code on the internet and lets people collaborate about it. GitHub's got a really nice affordance called a pull request, which is basically when Miss Salamander wants to put that house back in, swap it with the original house, she gets to radio all her coworkers and say, I think this house is ready to go back, but can we talk about it for a minute? And then in real software terms, that tends to be the moment that they get a code review. This is a session report. If you've been around testing for a while, you may have heard of session-based test management. This is basically a technique for exploratory testing where a tester has a mission and then they spend some time trying to figure out the answer to whatever questions they had about the software. And there's a sort of a standard template that I have used over the years. I stole it from James and John Bach. They had a paper about this many years ago, and I've been using this report format ever since. So what we started doing is at that moment when the developer says, okay, this software is ready to ship back into the master branch, I then do this exploratory testing session. So as you saw at the previous slide, we had like the charter and the tester and the spot for the notes. This is me putting this information into the pull request. And it's got some handy standard places. In the charter format has got a place for bugs, a place for issues, and a place for risks. The bugs are the things that need to be fixed before the branch merges with master. That is to say, like, I found that there's a leak behind the shower, so we need to fix that before we replace it with Mr. Frog's house, right? Issues are questions that I want to be answered. That might be something like in our house metaphor, maybe the turtle said, did you really intend for the shower to be white but the toilet to be brown? Like things that might not necessarily be a bug, but might be something that people are worried about, right? And then risks are things that we still need to test before this thing merges. So like, for example, when I'm doing testing and I get a pull request at the end of the day, I might spend a half an hour testing something and say, okay, I found this bug, I have this question. In addition, I want to run these other 10 tests before we merge this thing so that I can put this in as a checklist there. So with that technique, we're trying to achieve first-time quality. And when we say first-time quality, we mean when we say the thing is done, it's actually done as opposed to just being like dev done. Okay, so challenges with the branch. Any questions about any of that before I go into some more detail about the things we had to overcome? James.
For your first time quality, is there a certain bar that you set that at?
Yes.
If so, what is it?
Well, the bar that we are setting, the question was, oh yeah, you had a microphone. What is the bar for quality that we want to set? And the answer is that the software should be releasable all the time. We want to make it so that we are comfortable selling Camtasia for $200, which is what it costs, at all times. That requires a bit of process discipline and some things like feature switches in order to make it happen, but that is our standard. So the first challenge that we had was that builds take a long time on Camtasia. As I mentioned before, it's got a lot of history. There's a lot of code there. It's a code base that's got like 100 projects of C++ and C#, which if that means anything to you, it's a lot. And it takes about an hour to build because there's a signing step and there's 3 different languages. So once you press the button, it's about an hour before you see an installer spit out. That was taking a really long time, and that didn't give the developers and the testers the kind of back and forth conversation that we wanted them to have. So what we did for that is that we got Camtasia building in IDEs for all the testers. So what that means is that all the Windows testers for Camtasia are using Visual Studio, all the Mac testers for Camtasia are using Xcode, and everybody learned how to do Git so that we could pull down the branches and then build them inside the IDEs. Some side benefits of that, in addition to the speed gain that we got, another side benefit is that when you're using the installed version of Camtasia and something goes really wrong, you just get a pop-up that says, Camtasia stopped working. And then it crashes, and then you either got to go find a bug, like a crash dump, and try to send that to somebody. When something really bad happens in Camtasia when you're running it in debug in Visual Studio, the really bad thing that happened pops up in your face and says, I'm the really bad thing that happened. And then you can just take a screenshot of that, and then you hand that screenshot over to the developer that's sitting by you. Another side benefit of that is that bug fixes on branches can be tested in moments. So when I say, okay, hey, Miss Salamander, there's a problem with the toilet. And she's like, oh, type. I fixed the toilet, pull down from Git again, and I can just type a couple of commands into my command line and then build it again. And I can say, oh, it's fixed. And that is orders of magnitude cheaper than me writing up a whole bug, putting it through a bug triage process, figuring out whether the business people care about it, and then having a developer learn about it, the software again so that they can go and fix it. It's just massively faster. Here's a picture of myself working with one of my developers. Now, this is from War Games, but yeah, basically this is what the developer tester interaction basically works like now. So you find something. The developer walks over and goes, that's not supposed to happen. And you say, okay, this is what I did for it to happen. And then they go back to their desk, they can fix it, they send it over to you, and then you can retest it. So that was how we solved the problem of the builds taking a long time. Second thing was the problem of limited tester availability. We have about a 4 or 5 dev to tester ratio. So there's a lot more code coming at us as testers than possibly we could handle in this way, because the developers, they want to get their tasks done and move on to the next thing, and they want to get it tested before they ship the thing, right? And then some of us, I'll speak primarily for myself, but others also, I spend a lot of time in meetings because in addition to being a tester, I'm also a manager. And that means that a lot of times when a developer is done with their task, they ask me to look at it, and it might be hours or even more than a day before I can look at it, and that's not what we wanted, right? So how did we work on that problem? The mitigation for that was that once the developers saw what kinds of notes we wanted to put into the pull requests, they're like, well, if you want, I can just I did a lot of that testing myself when I was developing the thing. I can put a session report into the pull request just like you would, if that can make this process go better. And what ends up in practice is they put that stuff into the pull request, and then they signal to me or to the other tester who's working with another developer that they put this pull request out there and it's got testing notes in it, and then the tester can say, oh, that's really good, but I also would have tested these other things, and they can just put that into that conversation and in the pull request. And I can do that in a meeting. I don't even need to run the software in order to make a suggestion, right? And that way, the tester person can give QA thumbs without necessarily touching the software themselves. And what ends up happening, this is a process that I've seen happen on a few different teams, is you start out by doing the testing in trunk, and then you do the session reports and the PRs, and the developers gain that insight that things could go faster because they could be putting testing notes into the PRs themselves. And then they just, rather than asking QA to test for them all the time, they start asking QA how to test themselves so that they can learn to be better testers themselves. And then testers start to move into sort of a testing coach role in addition to doing the manual testing.
Does that slow down the process of testing, or the development? If the developers start testing themselves, does that slow down the process, or does that make it faster?
In the micro scale, it seems like it's going slower, but if you go even just a little bit above the micro scale, it's much faster, because finding things sooner makes them cheaper to fix. And the earliest possible opportunity to find a bug is right after you coded it. So when that person does a little bit of their own testing and then they say, oh, that didn't work, and then they can just fix it. They don't even have to tell anybody about that, they can just fix it, right? So if your developers get better at testing through this process, then the number of bugs that end up getting shipped is much smaller, and like you'll have a higher quality by the time it even reaches you as a manual tester. Does that answer your question? Okay. This third branch testing challenge was sort of a surprise to me, because it gave me sort of an insight about myself as a tester and what my motivations are. Part of how I get self-esteem as a tester is I log bugs in the bug tracker, and then somebody says that they're important. Like, your product owner says, that's a must fix. We definitely got to do that. That's now a work order for somebody. And you say, wow, I created value for the company. I logged a bug. When you are doing this process, you end up logging many fewer bugs than you used to. I looked at the way our bug tracker is working now, and we have a lot of bugs logged in our GitHub repository, but more than half of them were logged many months ago. Most of them have been, very few of the bugs that we're talking about in our bug tracker now are actually have been logged recently, because people are doing this process and these bugs are getting fixed much faster, but the business people don't find out about them anymore, because it's just a conversation between the tester and the developer. So that means that it's not as visible to the business what the testers are contributing. Now I'd say we have a very healthy culture here at TechSmith, and I don't worry that much about the business people saying that the testers aren't doing anything, because they know what we do. But if we didn't have that relationship, then it would be harder to prove the value of the testing department. So mitigations for that, again, I don't really have a great answer for this. All I know is that on my team, it hasn't seemed to be that big a problem that the management community doesn't think that the testers are doing anything, but I can imagine that could happen on a team. So is it working? I can say that it's working for us. And the proof is that when we wanted to ship 9.0 last year, we had that moment where we said, oh my gosh, there's 100 must-fix bugs. Can we get them fixed in the next 2 months? And we did manage to hit the date, but it was really scary, and they had all these horrible meetings about like which must-fix bugs are going to become want-to-fix, and that nobody wants to have those meetings. And it was just that experience wasn't great. But now when we want to release, one of our product people just goes to one of our pods and says, we want to release a maintenance version. And they say, okay, we have to go through our release process, which involves working with our web presence people. And all that takes about a week. And that's how we can ship Camtasia now. Instead of being a months-long process with everybody running around with their hair on fire, it's one pod working for a few days to get the thing out into the internet. And that's what we have to do now. So yeah, we're releasable at all times. We're logging and triaging fewer bugs, as I mentioned. And we like it better because releasing is a low-stress activity. The relationship between developers and testers is a lot better. One of the things that kind of stinks about the ready for testing column and the idea of putting things back into a in progress state, like if you get a card that gets moved to an in testing state and then you say, it didn't work, I'm putting it back to in progress, is that it feels like you're telling the developer that they did their job wrong, which I don't like to do. I would rather just work with a developer to help everybody get the thing right the first time. And I feel like the developers feel better in this type of relationship. And as I mentioned, their quality is improving. And we use, basically my test for that is whether we can release all the time and whether or not support has been telling us that things are going well. And support tells us that things are going well. Mr. Norris.
So I'm just curious, Clint. You're, I think you're right on the interactions between testers and devs and having that fast cycle time. If you have and I'm not accusing anyone here, but if you have a bad manager, it's sometimes easier for them to cop out and say, well, I'm going to measure your performance on the number of bugs, the bug count, because I can just go get that number and say you're good or bad. Measuring your performance in the way that you're describing, which I agree is better, is harder. I mean, for the testers here that might have that problem, what would you suggest to them to help managers learn better ways of managing testers in the way you're describing?
Let's see if I can restate that. So how could testers demonstrate their own value if their manager was curious about whether they were performing?
How do we keep managers from reverting to an oversimplistic way, set of metrics from their testers? What maybe you'd call it old school test measurements, and really measure them against how well they execute against the agile principles within a team.
I think that probably the most sensible way for the tester to be measured in this scheme, it's really not the tester that should be measured. It should be the pod that gets measured if you're going to be measuring things. How fast are cards moving through the process and at what level of quality? Like if other teams are saying that team keeps shipping bugs that end up in trunk, and I keep on when I pull develop and everything's busted and it's always that team, then that would be a signal to a manager that something's going wrong.
There may be obstacles to doing that. For example, if your HR system isn't really set up to measure that way, if they're more individualistic, that will be harder, right?
Yeah, I got to say that we haven't really. My experience at TechSmith we've never really used like quantitative measurement of people that way. So I don't have any experience in trying to like make up for the fact that we're not doing it. Did you have something to say, Matt?
I can comment. It would be helpful.
Sure. You got a microphone over there?
So this may be a bit of a stretch, right? But I've worked with, in the course of what we do, I get to work with a lot of companies, right? And there are a lot of these bizarro HR systems that are, we have to figure out how to rate people from 1 to 5, and I want it to be defensible, so I want to pull something out of a database to help me, so we're going to use bug count or something like that. In my experience, there's really only a couple of ways to overcome it, right? A good manager, well, one approach, as a new manager with a team, I don't know the people yet, I'm being pushed to give numbers. Everybody's a 3 this year, like you're all 3s. Right, till I figure out what the heck is going on. And then I got to figure out how to manage and give answers that can be defensible. And that usually, like, as a manager, you won't get fired for doing that. It's, and if they can't see that as an option, if they're like, no, I need metrics, they've got to be defensible, I'm going to pull what we have on the database and this is what we've got. Like, that's a bad manager, right? So, like, how do you solve the problem of bad management? It's more like a master's course than your 10-minute presentation. I think it's sort of out of scope. Can we call it out of scope? It's really interesting, though, and I'm happy to talk about it after.
I think that again, part of it has to do with sort of the health of the team and the quality of the managers that are working with you. If people are competent and your managers are doing what they should be doing, then it hasn't ever been a problem for me that the managers thought that the testers weren't doing what they should be doing.
I was gonna say a comment too.
Okay. She's got. She's holding one.
I know from personal experience of, I guess, seeing things change over the years and different techniques to try to measure, how QA or a team is doing. I know one of the things that we've tried in the last year or so has been to see what has been the outcome of our releases. So if people are coming back with bugs or commenting, we have trends of that. So we can see what's working, what's not over time. And that kind of becomes the measurement instead of just like, oh, well, you found 5 bugs before this release, so that means it must be good. Well, that doesn't mean it must be good.
Right.
There's a lot of different factors. You may have devs that are just out of college. This is their first job. They're learning. You may have senior developers that have been working with the same code for years. So to say like, oh, you found 5 bugs as opposed to 10, which one is better? That doesn't really make any sense. So the real measurement for us is just after the fact.
So escape defects, basically.
Right. And then from there, seeing the trend of what's working and what's not, as we try to change things or try TDD or try, include all these different things, that becomes the measurement. And, it's not just like 1 month worth of measurement. Obviously when you're getting reviews, it's over the year, per se. So that seemed to work for us. We had to evolve to get to that place. And we're still trying to evolve that, but that's one way to measure it in some ways.
Okay, thank you. I think another reason why looking at your escape defects can be valuable is because they can show you what your blind spots are as a test team. I know that on Camtasia we did an activity where we looked at all of our escape defects that came from users, and we affinity diagram them, we moved them together to say, okay, what is our worst problem? And then we discovered basically our worst problem is that we don't know what kinds of weirdo videos people are going to be trying to import into Camtasia. Which, if that's what people are calling support about, then it's important, right? All right. Okay, so I talked about we actually have a 3-tiered approach. I like to think of it as like 3 exploratory sieves that try to stop bugs from making it into the product. The first one is the testing in the branches. The second one is what we call mob testing, which the way that we do this is that when a feature is getting done, then everybody from Camtasia QA, or even from QA outside of Camtasia, will get together and we'll do a mind mapping meeting where we go through the heuristics that we know about for thinking about test ideas, and we try to come up with, we try to brainstorm any test ideas that got missed during the branch testing phase. And that usually gives us a bit more confidence that either we did really well or that we need to go back and check some things. And lastly, so all of this is about finding explicit and implicit requirements, right? But I also talked about those latent requirements. How do we check for latent requirements? And the way we do this thing is we do what we call whole team scenario testing. The techniques that go into scenario testing could be a whole talk of their own, but basically, as a nutshell, we get the whole team together and we say, here is a mission that a customer would try to accomplish. We want you to spend the next day or two trying to accomplish that mission as a customer. What we found over the years is that you can really drive engagement for this thing if you try to make it fun. Ways that we try to make it fun is we make it a competition. We put people into teams and say, okay, I've historically done it, either I divide the entire team into half and have the 2 teams play against each other, try to find more bugs, or what we did more recently is that my coworkers Sydney and Pam, who are actually right over here, they put together what we called the Fossil Film Festival, which was a activity where we put people into teams of 2 and 3, and we asked them to make marketing videos that look like the videos that you see on the internet. And then we had people from marketing judge those videos to see how good they were. And the people who won that, they got little trophies that the team put together. So an observation that I'll make is that you want to have prizes for these things because people get motivated by that, but you also want the prizes to be worthless, because if they're worth something, then people get mad about fairness, which that's not the point of the activity. Okay, so restating the strategy, how do we try to get quality into Camtasia? We test for explicit and implicit requirements before we merge. We utilize our cross-functional expertise. The developers work with the testers, and the testers work with the developers to reduce handoffs and learn from each other. And then we try to discover those latent requirements by doing these user empathy exercises like the whole team scenario testing. Okay, anybody have any questions? That's all I got. Back there.
I was wondering if you guys have any sort of automation for your testing so that you don't necessarily always have to manually test, but what parts could be automated to where that can be repeated easily?
We do have automation around some things. Like I said, it's a legacy product. It's got 16 years of code in it, so it's not that easy to automate every aspect of it because, for example, TDD was not a well understood practice back in 2002. But we do have some sets of automated regression stuff. In particular, a widget that we just got at the beginning of this year is what we call like golden frames tests, which means that if you have an existing project, you can have Camtasia spit out a video, and then we'll use computer vision to see whether or not the video looks like it did on a previous version of Camtasia, so we can see if we have any regressions in the ways that we make videos. That's an example. We're also trying to wrap all new code in unit tests, and also we're trying to, we have a thing now where we're automatically testing our upgrades to see whether or not our upgraded file, the upgraded version of Camtasia has the same files in the file system as a new version of Camtasia. What we have not tried to do yet is go back and automate regression. What we do instead is we do those whole team testing activities, which tends to shake out the bugs that the business would find important. Because if we were to make an automated test for a business rule that was written into the product 15 years ago, and it doesn't work now, we might not even choose to fix that. So instead we try to like design our activities around things that the business would want to fix if we were to find it. Did that answer your question? Okay. Matt's got a question?
Again, as a comment, is that all right?
Sure.
All right. So I think it's probably worth noticing, this is a Windows product.
Mac and Windows, yeah.
Yeah, and particularly Mac and Windows, the test tooling, it's more problematic. There's more false errors and stuff breaks when things change that are fine. It's just that we move the button over there than some of your Windows stuff or some of your web-based stuff. And it's worth noting they had a test automation team. Was that for Snagit, or did they also test Camtasia?
We used to have a test automation team here at TechSmith, and they were sort of their own service that like got checked out by product teams.
Right. And
years ago.
People didn't really understand what the value they got, and they don't have that team anymore.
Yeah.
So we might consider that an experiment. That's probably another talk too.
Yeah, sort of a postmortem on why that didn't go great would probably be a scope for a lightning talk of its own. Yeah. Yeah. Teresa?
I think this is
It's not on.
Oh, okay.
There you go. Blue, green, okay. So I know like that this has been a good presentation. I think luckily you guys have a product where it's kind of enclosed in its own package.
Yeah.
One of the things that I know my product has run into is that working on branches isn't necessarily helpful for all of us because we have multiple teams working on the same product. So if you have each team working on its own branch and then you merge it all in together, oh no, what just happened? So you have that issue with some bigger products and depending on the type of product. And then also, because this is an enclosed product, one of the things that also I've kind of noticed with the discussion was that, okay, we talked about the branches and whatnot, but besides the code branch, we also have like, oh, what version of the database do we have? Is LDAP working? Is like all these different components that are outside of just the code branch.
Yeah.
So like, oh yeah, like this works right now, but then, oh, we just deployed this to another environment. Oh, this other stuff isn't there. So now that doesn't work. But the branch is right, but all these other components aren't there.
Right.
So, I think this was like a simple case for the demonstration, of course, but there's tons of different products out there that have all kinds of...
This is working well for our context for Camtasia. I'll state it like that. So this is a little bit more inside baseball, but like what I have basically described in this presentation is what's called Git flow. But we're not actually doing Git flow on Camtasia. What we're actually doing is what's called trunk-based development using pull requests. So our branches are extremely short-lived. They only last like a day. And then when we find out that when the tester gives the thumbs, then it goes straight back into the trunk. So that's how we've tried to work around that problem of multiple teams working in there. And that has necessitated the heavy use of feature switching. So like you have to configure partially completed features on and off to say that the users can't see this thing because there's a lot of, pardon our dust, right? So that's how we've worked on that first problem. I don't have a good answer for the second one besides like have dev environments or something as opposed to working locally in your own. And that's how our cloud people do it. They have dev environments instead of building locally. Yeah. Anybody else? Okay, thank you very much.